Good morning. I'm Pranava Swaroop and from SVC College of Engineering, and today I'm going to talk about solar photovoltaic systems and its applications. The contents of this video are introduction, types of solar PV systems, different components of solar PV systems, and photovoltaic applications. Introduction. A photovoltaic system, also PV system or solar power system, is an electric power system designed to supply usable solar power by means of photovoltaics. It consists of an arrangement of several components, including solar panels to absorb and convert sunlight into electricity, a solar inverter to convert the output from direct to alternating current, that is, from DC to AC, as well as mounting, cabling, and other electrical accessories to set up a working system. It may also use a solar tracking system to improve the system's overall performance and include an integrated battery. So this integrated battery will store the current and will be used even when there is not much sunlight. Types of solar PV systems. There are three common types of solar PV systems: grid connected, hybrid, and off grid. These PV solar panels supply electricity to customers by converting the sun's energy into solar energy using different techniques. Now I'm going to explain these in detail. Okay, first we have grid connected solar photovoltaic systems, also known as the utility interactive PV system. This photovoltaic module uses a basic grid tied inverter. It does not require a battery to operate and has essential components. It transforms PV solar energy into AC power through the inverter. Basically, the inverter converts DC to AC. It is practical solar PV module that reduces the overall electricity consumption. As you can see here, these are the solar PV modules. That are the solar panels, and this is connected to the inverter, which converts DC to AC. And this is connected to the utility net meter, where the meter knows how much current is flowing through it and how it segregates the current. And this utility power line. Next we have hybrid solar photovoltaic system. These PV modules are a modified version of a grid tied system and consist of a battery backup. It is integrated with diesel generators and converts energy to AC or DC voltage. So it is similar to the previous system, that is grid connected solar system, except it has a battery backup bank. So this battery actually stores all the current in from the solar panel when it's not in use. So it can be used later on whenever it's required, even when it's not sunny. Basically, even at night time, you can use solar power which is stored in the battery. Next, we have off-grid solar photovoltaic systems. It is an ideal device for people who cannot use grid-connected solar photovoltaic system due to geographical restrictions or high cost. Different components of solar PV system. A solar PV system has various components, but every solar photovoltaic system has six main parts. That is a charge controller, the solar PV array, a battery bank, a utility meter, an inverter, an electric grid. Also, the battery bank and charge controller are optional components. They help to store additional solar energy for use at night or during the rainy season. The role of each element of solar photovoltaic panels is as follows. The PV array aids in converting solar energy into DC. The charge controller keeps the battery safe from overcharging, as overcharging can cause an explosion. The battery bank stores extra energy from the sun for future and emergency use. The inverter transforms DC power into AC electricity. This is essential in supplying the required energy to the household appliances. As you all know, household appliances run on AC current, so the DC current from the solar panels must be converted into AC before it can be used or put in through the main house line. So that is done by the inverter. And the power meter determines the current required for household purposes and amount that is sent back to DC. At night, the electricity is sent via the electricity grid. Photovoltaic applications. Now, there are many applications of PV cells or panels, and I've just listed a few of them. First one is solar farms. Many acres of PV panels can provide utility scale power from tens of megawatts to more than a gigawatt of electricity. These large systems use fixed or sun tracking panels feed power into municipal or regional grids. So in solar farms, you have many planes of solar panels that are interconnected and that produce a lot of power, like megawatts to gigawatts of electricity. That's a lot of power. So these can be used to fire up an entire grid of electricity and supply it to a village or whatever. Next, we have remote locations. It's not always cost effective, convenient, or even possible to extend power lines to locations where electricity is needed. PV can be the solution for rural homes, villages in developing nations, lighthouses, offshore oil platforms, desalination plants, and remote health clinics. So, there are some geographical locations where power lines cannot be extended, and the use case might be very low. For example, a small village would require less power, and a lighthouse would require very less power. So it's not practical to extend an entire power line just for that use. So in these cases, solar power would be the best use. Since you don't need a lot of connections from external places, you're making your own power through the solar panels and you can place them wherever you want in nearby location or on top of your roof or whatever. So solar power would be the best in these cases. Next, we have standalone power. In urban or remote areas, PV can power standalone devices, tools, and meters. PV can meet the need for electricity for parking meters, temporary traffic signs, emergency phones, radio transmitters, water irrigation pumps, stream flow gauges, remote guard posts, lighting for roadways, and more. You might have already seen the roadway lightings and solar powered traffic sign signals. It's a very effective use of solar power. And next is power and space. From the beginning, PV has been a primary power source for Earth orbiting satellites. High efficiency PV has supplied power for ventures such as the International Space Station and surface rovers on the Moon and Mars, and it will continue to be an integral part of space and planetary exploration. So, for satellites or rovers, the solar energy is the only source of energy since there are no power grids or lines that we know of. That is the only form of energy currently available. Next, we have building related needs. In buildings, PV panels mounted on roofs or grounds can supply electricity. PV material can also be integrated into a building structure as windows, roof tiles, or cladding to serve a dual purpose. In addition, awnings and parking structures can be covered with PV to provide shading and power. There can be a parking space where the roof is completely made of solar panels and hence it acts as a roof as well as, well, a solar panel that gives energy. This will provide shade to your car as well as charge your batteries. Next is transportation. PV can provide auxiliary power for vehicles such as cars and boats. Automobiles sunroof can include PV for onboard power needs or trickle charging batteries. Lightweight PV can also conform to the shape of airplane wings to help power high altitude aircrafts. We can see photovoltaic cells being used in automobiles, such as cars and boats. These are usually put on top of the sunroof or used as a sunroof. They are used for trickle charging or onboard power, especially for infotainment system in a car or a boat. And that's all we have for today. Thank you. I hope this video was informative. Please like and share.